Hello viewers, welcome back to another section of my multivariable calculus tutorial. In this video, we are going to talk about change of variables in multivariable. So if they give you any multivariable functions, that is when you talk about double and triple integrals, and you want to make change of subjects, we apply what we call the Jacobian. You have to convert it into a new variable, but you need the Jacobian. So in this video, the main focus is to solve problems, and we are going to compute the Jacobian of some transformation given. If this is your first time visiting this channel, don't forget to subscribe, you like, then you also share the video. Please watch this video to the end so that you understand every part of the video. So I have my first transformation, which is x is equal to 4u minus 3v squared, while the y is equal to u squared minus 6v. The second transformation is s is equal to u squared v cubed, while y is equal to 4 minus 2 root u. Final transformation I have in this tutorial is s is equal to v out of u, then y is equal to u squared minus 4v. Now let's begin. So let me take the first one, which is saying that I have s which is equal to 4u minus 3v squared, right? Then I'm going to have its y to be equal to u squared minus 6v. So to find the Jacobian, someone asks, what's the formula or how do we get it? So the Jacobian is simply the determinant. You draw your determinant symbol, but if it is a 2 variable, you're going to have a 2 by 2 matrix. If it's a 3 variable, then you're going to have a 3 by 3 matrix. So once you have our determinant drawn, the first entry here on the column wise will be for a particular u. So what we're going to do is you find the x over the u, then we come down to find the y over the u. So the first column is purposely for one of the variables u. Then when we come to the second part, we tackle v. So the x over the v, then the y over the v. So once we have this, then we move straight making our substitution. What is the x du? You realize that the x du is simply equal to 4, right? So if you are different, if you want to find the derivative of this with respect to u, then everything which is not u is going to be a constant. So you realize that this whole thing will turn 0, so I'm going to get 4 here. When I come here, dy du is going to give me 2u, right? So I write my 2u here. Then when I come to this side, the x dv, I'm going to get negative 6v. Then my dy dv, negative 6. So it's simply like finding the determinant of what I'm having here. So let's see. When I have this, I'm going to multiply the term on the principal diagonal, then I subtract the product of the other components. So I'm going to get 4 multiplying negative 6 minus 2u multiplying negative 6v, right? So this is going to give me negative 24, then this is going to give me minus, so this is going to give me minus 2u, so I'm going to get negative 12uv, right? So this is going to give me negative 24 plus 12uv, and this is simply our Jacobian for the transformation, as simple like that. Let's see the second transformation. So transformation 2, you have x is equal to u squared v cubed, then y is equal to 4 minus 2 root u. So as we did in the first part, we find our dx du, and the x du here, you know, v cube becomes a constant, so I'm going to get 2u v cube, right? Then I come here, the y du. What is the y du here? This is the same as y is equal to 4 minus 2u to the power half, right? So if you want to find with respect to u, you multiply half by what I have here. That's going to give me -1. Then I subtract 1. So I'm going to have my dy du to be negative u to the power negative half, right? Then when I come to this side, I'm going to find the x dv. So the x dv here is going to give me 3u squared v squared from this side. Then when I come here, I'm going to find the y dv, and you realize that there is no v term here, so it's simply 0. So when I have it this way, it's like finding the determinant as we did. You multiply terms on the principal diagonal, then after you simply subtract the product of the other diagonal. So here 2u v cube multiplying 0, then minus, I have my expression 3u squared v squared negative u to the power negative half, right? So this whole thing becomes 0. Then we are only left with this side, so I'm going to get negative of the expression. I have 3u squared v squared multiplying negative u negative half. Let's simplify this further and see what we're going to get. So I'm going to get, now u here is 2 and half here, so I'm going to get 3 out of 2, so negative 3 multiplying u 3 out of 2, so the negative will multiply negative, making positive, so 3 out of 2, then I'll have my v squared. So this is simply my Jacobian for my transformation. Finally, let's find the third transformation, and the third transformation is simply x is equal to v out of u, then y is equal to u squared minus 4v squared. So I simply draw my determinants. Then my first entry here, the x over du, what is going to be that? So here realize that v is a constant and it's going to stand out. So v will stand out if I have s is equal to v over u, and I want to find x with respect to what? U. This is simply equal to v standing out, but for this side it's going to be, this is the same as u multiplying, u to the power -1. So I'm going to get negative u to the power -2, right? That is negative 1 over u squared. So let me come here and put it inside. So I'm going to get negative v on u squared here. Now I come here, divide the u, that will give me 2u. Then I come here, the x dv will simply give me 1 over u. Then dy dv will give me negative 8v. Then I simply do my computation, which we are already conversant with that. So I'm going to simply multiply negative v over u squared multiplying negative 8v, then minus 2u multiplying 1 over u. So negative with positive, then I'm going to get v squared 8 here all over what? U squared minus u, cancel this 2, right? So this becomes my Jacobian for the transformation. Thank you for joining this class. Kindly subscribe if this is your first time, and also like and share. Don't miss out the next tutorial.